Last section, rational equations. You're almost done Algebra 2. Hang in there for one more section. Okay. A rational equation contains at least one rational expression, like fractions. So what we do to solve a rational equation, because there's variables all over the place, is to clear the equation of the denominators. How do I do that? Well, we multiply both sides of the equation by what would be the least common denominator. Like as if we were going to actually add them together, but we're not going to. And you're going to see that this makes solving this hideous equation a little less horrible. Okay. So the first thing you want to do then is find the least common denominator. But that's going to require you to do any factoring, and that's why we practiced that in the last section. So this is the problem that we're going to solve. So the first thing I'm going to have to do is I'm going to have to factor. So I just retyped this part here so that I wouldn't have to write it again. So, of course, x squared minus 1 factored is x plus 1, x minus 1. And that is, in fact, the least common denominator. So we're going to multiply both sides by the least common denominator. So I'm going to put a big set of parentheses here, a big set here. And I'm multiplying both sides by the least common denominator. Now on the right side, that's pretty easy because this is going to cancel with this and we're just left with a 2. It's a little bit more complicated on the other side, but it's not really that bad. So in this purple set of parentheses that are now blue, there are 2 terms. So you are distributing this to each one of these fractions. So I'm just going to write over here on the side. So we have x plus 1 times x minus 1 from here times x over x plus 1. What happens? Well, these are gone. And now I'm just left with x times x minus 1. Well, that's much better. When I distribute the purple to the second fraction, I have x plus 1 times x minus 1, that's the purple part, times x over x minus 1. And now these cancel, and I'm left with x times x plus 1. Now, this equation here is a lot easier to deal with than this gross thing up here. I hope you agree. So now we can distribute this x. We get x squared minus x. We'll distribute again. We get another x squared, but now it's plus x. Combine like terms. Don't forget when you square root both sides, you get plus or minus. So we got x equals plus or minus 1. But don't forget that this is a rational equation, and so you run the risk when you're multiplying both sides of introducing extraneous solutions. So you have to check to make sure that these numbers here that we got for answers are for real. So let's go back and look. What did we learn how to do in the last couple of sections? We learned after we simplify, add, subtract, multiply, divide, whatever, you have to say what x can't be, right? Well, in this problem, x can't be plus or minus 1. And those are the very answers I just got. But I already know that x can't be plus or minus 1. So this is a fake out. This is really no solution, because the only solutions we got didn't really work anyway. Okay. So you definitely need to check your answers. You don't really get answers that when you plug in will give you the wrong number. I've only ever seen where you get a number for an answer, like plus or minus 1, where it's excluded from the domain. So for instance, if you had gotten, I don't know, like x equals 3, you don't have to go and check that. You just have to make sure that x is actually allowed to be 3. Of course, you can always check your answer, but... Okay, so let's come down here and let's work on this one. So we have this equation here. So I'm hoping that you're going to remember the first thing we do is any possible factoring, at least in the denominator. And so x squared minus 9 is, oops, that's just not true, x minus 3, x plus 3. And if you look at all of these denominators, x minus 3, x plus 3 is the least common denominator. So that's what I'm going to multiply both sides of my equation by. Okay, so on the right side, this is pretty easy because this just cancels out with this, and we're just left with, oh, it's a 2 again. Isn't that weird? Okay, on the right side, I'm multiplying the purple by the first green. The x minus 3's cancel, and I'm left with x times x plus 3. I'm going to change this because this looks, that looks like it's division, and it's not, so we're timesing by x minus 3, x plus 3. All right, I think that's better. Okay. When we distribute the purple to the second green fraction, the x plus 3's cancel, and I'm left with x times x minus 3. Okay, so we're going to distribute. Simplify. Don't forget you get a plus or minus. And you take the square root. Again, weird to get x equals plus or minus 1, but do they work? Yes, they should be fine. Now see, I'm not actually plugging them in, but I go back and I look at the top, the original equation, and say, did I just find answers that are excluded from the domain? No. The numbers up here, the x can't be, are 3 and negative 3, and I got plus and minus 1. So these should be fine. All right, let's come over here. This is just we're just practicing the solving equations. There's not really much more to it than this. I'm just going to walk you through solving a bunch of these. Okay. What do you notice here? Now, this could be factored, but does it matter? Because they already have the same denominator, don't they? I'm sorry about that extra noise. It's the last video though, right? Okay, so if we times both sides by x plus 2, it's going to cancel all of the denominators. And now I have this little equation. All right, well, it's not that little, but... All right, so hopefully you can see here that this is a quadratic because of the squared. So we're going to subtract the x and add the 1 over to the other side. And we're going to get minus x plus 1 plus x minus 2. Okay. And now this is a quadratic. So hopefully it can be factored. But remember, there's lots of ways you can solve a quadratic equation. There's factoring. There's taking square roots. There's quadratic formula, completing the square, graphing. If I forgot one, sorry. I was going to say let me know, but yeah, this isn't live. Okay, so this can be factored with a 2 and a 1, so that's good. So that means I'm going to get x equals -2 and x equals 1. But don't forget, you got to go back up and check. So go back and look at the original equation. I'm going to erase this just so you can see it a little more clearly. What can't x be up here? -2. Didn't I just get a -2? Oh, that's not okay. So we're going to cross him out, but we're just going to keep that guy. So these are some good examples. So far we have one that had no solution at all. Neither numbers could work. I got one where both work, and I got one where one doesn't work and the other one does. Okay. All right, let's try this one. This doesn't need any factoring, so that's nice. So the two denominators are x plus 1 and x plus 4. So my least common denominator is going to be x plus 1, x plus 4. And so that's what I'm going to multiply both sides by. I'm such a cheater, aren't I? Look at that. I don't even write it again. I'm kind of loving this video stuff. I know you probably hate it, but okay. So nothing here is going to completely cancel out. Let's deal with the right side first. So when I distribute this, the x plus 4s are going to cancel. And I'm going to be left with x plus 3 times x plus 1. Now I'm going to have to deal with that, but I'm not going to deal with it right this minute. Okay, so remember, on the left side, you have to distribute. So this whole blue thing, well, that's now circled in purple, is getting distributed to the first fraction and then again to the second fraction. So when you distribute it to the first fraction, these are going to cancel, and we'll just be left with these. I'm just going to move a little bit over to the side because I'm afraid I'm going to run out of room. So the x plus 1s are canceling, and I'm left with the x and the x plus 4. Oh, that's not what I wanted to do. Oh, there we go. Okay, that was like, it was too much to look at. Plus. This plus here, that's coming from this plus here, just so you're aware. I'm not just making it up. Okay, when you distribute this to this, the x plus 4s are going to cancel, and we're going to be left with 3 times x plus 1. And now I have no more fractions. On the left side, I'm going to have to distribute, so x squared plus 4x plus 3x plus 3 equals, and then over here on the right, it's a FOIL problem. I'm going to clean these up. The bonus about this problem is that the x squareds actually go away, so that's helpful, because if we subtract x squared from both sides, they're both gone. So this is actually not a quadratic anymore. So I'll subtract 4x from both sides, get 3x, subtract the 3's, but that gives me a 0. So that means x has to be 0. Can x be 0? I don't see why not, because the things that x can't be are -1 and -4, and that's not what I got, so x is 0. That should be fine. All right. This one here, this one's pretty easy, I think, because the denominators are already the same. So when that happens, you're in luck. Oh, there we go with the noise again. Okay, so that's canceling. That's canceling. I get 4 equals x minus 1. So x is 5. No reason x can't be 5, so that's fine. Let's come over here. Now here, they're still rational functions, but the fractions are numbers, so there's no variables down there. That makes it a little bit easier. So the least common denominator would be a 6. So we're going to multiply both sides by just the number 6. on the right side, the 6 is going to cancel with this 3 to make a 2. So that's going to be 2 times the numerator, which is a minus 1. When the 6 distributes on the left side, these 6's will cancel. I'll just get 2a plus 1. When the 6 gets distributed over here, the 6 is going to cancel with the 2 for a 3. What might be helpful, I didn't think about this until now, but let me get rid of that for a sec, is when you find the least common denominator, the 6, instead of saying times the left and right, you could times each individual term. That might be more helpful, because now that this 6 is closer, it's a little easier to see that that's a 3 now. That might be helpful. So keep that in mind. 2a and 3a is 5a plus 1, distribute 2a minus 2. We'll move the 2a over here, and we'll move the 1 over there, and I get a equals negative 1. Now, in this rational equation, because there were no variables on the bottom at all, there was nothing that a couldn't be. It's not x, so there's no reason a can't be negative 1. Okay, this one requires a little more work. So I'm going to have to factor anybody who can be factored, at least in the denominators. Of course, there's always a chance that you factor the top and the bottom, and then you can like cancel something and then just make your life even that much easier, but that doesn't usually happen that often. Okay, so the least common denominator is this purple thing. So we're going to multiply both sides by the least common denominator. And I'll do what I suggested in the previous problem on this one, so you can see. Okay. Because when you multiply the whole side, you're distributing. So you really are multiplying everybody by the least common denominator. Okay, so when we multiply nn plus 1 times 2 over n, the n's cancel, and I'm left with the 2 times the n plus 1. When I multiply the next one, nn plus 1 times n plus 2 over n minus 1 plus 1. Those cancel, and I'm left with n times n plus 2. And on the right side, this just cancels all together, and I'm left with negative 2. So let's distribute. Simplify, combine like terms. It's a quadratic, so we want everyone on the one side. And this is n plus 2, n plus 2. So then we get n equals negative 2. We get it twice, but that doesn't matter for this. So, okay. All right, so we're just practicing. So if you feel like you've got this, you know, I mean, you could just stop the video. You could just check the answers later if you want. So we're gonna factor this denominator first. Sorry, it's blurry when I zoom in. Okay, 3, 1. It's going to have to be a negative 3 and a positive 1. I shouldn't have thought about that too hard, because look at the factors. They're right over here. Okay, that is also the least common denominator. So that's what I'm going to use to multiply both sides. I'm going to run out of room. There we go. On the right side, big canceling, just have the 8. On the left side, when I distribute to the first fraction, the x minus 3's will cancel, and I'll just be left with the x plus 1 times the 1. I should just put it there for now. And this one is subtraction, so I'm going to have to put the subtraction sign there. And then when I distribute the purple over to the other fraction, it's going to be the x minus 1's that cancel, leaving me with the 2 and the x minus 3. So now I have x plus 1 minus 2x. It's going to be a plus 6. That will give me negative x plus 7 equals 8. Negative x equals 1. So x equals negative 1. Can x be negative 1? It can't be negative 1 because look right there. Nope. So this is what I got as my answer, but that can't work. And there's no other answers, so that means this one is a no solution. All right, number 5 is pretty similar to the last one. The good thing about the factoring is you can usually figure out what it is because the other factors are sitting there. Okay, so the least common denominators, x minus 2, x minus 3. So that's what I'm going to multiply both sides by. On the right side, that will cancel completely and I'll just be left with a 1. On the left side, when I distribute to the first fraction, the x minus 2's will go, and I'll be left with x minus 3 times x minus 1 plus. And when I distribute this to the second fraction, it's the x minus 3's that are going to cancel, and I'll be left with x times x minus 2. So this will have to be FOILed. This x will have to get distributed. Minus 2x equals 1. That looks weird. I'm going to take that away. 2x squared minus 6x. Bring the 1 over. So then that'll be a plus 2. Now, this can all be divided by 2 because I could factor out a 2. But this is an equation, so if I divide both sides by 2, because this right side is 0, that'll just cancel. So here's my here's my quadratic. Do you see what the problem is? This is not factorable. So I'm going to have to use the trusty, wait for it, quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. I'm so sorry. It's back. Okay, so a is 1, b is negative 3, and c is 1. So x equals negative 3, so that's going to be a plus. Negative 3 squared is 9, minus 4 times a is 1 and c is 1, over 2 times a is 1. Simplify that. That's going to be 9 minus 4 is 5. And that's the end. That's it. So, a little unfortunate, but that's the way it goes. At least you have a formula. At least you don't have to use the rational root theorem. Okay, let's look at number 6. This one has no factors in common at all, so the least common denominator is going to be all of it. So the 3, the x, and the x plus 2. Okay, so on the right side, the 3's will cancel, but everything else will stay. I think, I'm going to duplicate this again and put it here. Oops. So when I distribute, well, I kind of already did, but so these x's will cancel, and I'll have the 3 and the x plus 2. And in this middle fraction here, the x plus 2's cancel, and I just get 3x. (3x plus 6 plus 3x equals x squared plus 2x. So 6x plus 6 equals x squared plus 2x. 0 equals x squared minus 4x minus 6. This is also not factorable, shocker. So negative b, so that'll be a positive 4 plus or minus the square root of negative 4 squared minus 4 times 1 times negative 6. This right here is going to be a positive 24 plus 16 is a radical 40. Radical 40 can be broken down into 4 and 10. So the square root of 4 is 2. Root 10 over 2. And then you can do some more simplifying. 2 goes into 4 twice. 2 goes into 2 once, plus the radical 10. And I've checked all these, so these, I like triple check them, so I know that these are right. Okay, last one. All right. This has got to get factored, but big shocker, it's just the factors that are on the other side. So that's x minus 3, x minus 4. X squared minus 20 on the top. Can't really be factored nicely, so I'm just going to leave it alone. Plus, you know what? It doesn't matter anyway, because you really only need to factor the bottom here. Okay. So this is going to be my least common denominator. So that's what I'm going to multiply everybody by. So the first fraction, these will cancel, and I'll be left with the 3 and the x minus 4. On the second fraction, the x minus 4's will cancel. And on the right side, everything cancels. Well, I mean, that with that. Okay, let's distribute. It'll be 8x minus 27. So we'll move everything over to the right side where the x squared is. So subtract the 8x, add the 27. Oh, it's on my page. Okay, I just want to make sure. But this one is factorable. Oh, thank goodness. Let's make sure that these are not excluded, but they're not, because the numbers that x couldn't be are 3 and 4, but I didn't get 3 and 4, so I'm good. And that, my friends, is officially the end of Algebra 2. See ya!